Okay, this is 11 o'clock. How many of us are in the group B? One, two, three. Are you in group B? No, if you're in group A, stay. I already said those in group A can stay. Yeah, it's okay. I've seen this. I've started it. Okay. All right. It's still morning. So, good morning, everyone. Yes, my name is Engineer Chidi Chugobian. I'm a software engineer. Um, and by God's grace, I'm the one that will handle this course. He The person that taught in the morning just came to assist me because I wasn't around on time. So you'll be seeing more of my faces than his in this class. Um, this course will run for minimum of 3 months, starting today. Because today is the first day we start, I like to allow us to call in God so that he can come and help us. That's my own tradition. I don't know if it's yours. Anything I'm doing, especially when I'm initiating it, when I'm starting it, I like to allow room for spiritual guidance. Maybe we don't know. God is a software engineer. He, he developed the software that run the world. So this world is programmed, and he is the one that programmed it. That's why when somebody tell you 10 p.m., you know that it is 9 o'clock. You know that it is night because it's programmed that way. And the first time you come on board, the first statement that God made that was revealed to us by his prophets, Prophet Musa or Prophet Moses, depending on how you want to call it. The first statement that God made on earth for us to hear is he said, "Let there be light." That was the first statement that God made. Let there be light. So in everything I'm doing, I like to say, let there be light. Because light means understanding. Light means wisdom. Light means no obstacle. Light means getting where you're going to without getting hot. Light also means happiness, joy, heart, your mind being calm. Because if you are in your room and there's no light in the night, towards even around 8, 9, when you are still having some activities to do, immediately light comes. There is a kind of joy that comes to your mind. Even if you're not on your TV, just to see that there is light, there's a joy inside. So light also brings joy. So God is intelligent. He exactly know what he's doing when he calling light to come. So in your own way, just say, let there be light in my heart, let there be light in this place, and let there be light in the life and in the heart of all the participants. Amen. All right. So talking about software engineering, that's the subject that we'll be discussing. Today we are starting the introduction to software engineering. And we say that software engineering is essential for creating reliable, scalable, and efficient systems. Why are we making this statement? Because someone can just start creating software without following the engineering process. Someone can, after all, some people think software engineering is writing code. So immediately you say develop software, they jump on their keyboard and they start typing on a particular programming language that they know. So why are we supposed to follow the rigors of software engineering? Because it's actually a rigor. By the time we start it, we see a lot of things that are involved in it. In fact, from software engineering alone, you can create about 4 to 5 to 6 other fields, other jobs that people can do. It's a very vast field for only one person to do. So why do you have to pass the rigor? That's what this thing is answering. That it is important because if you are to create a reliable software, reliable means people can depend on it. A scalable software that can increase with time as you are using it. A software that is efficient, that serves the purpose that it is meant for. Then you need engineering to do it. So we say that software engineering combines technical skills with structured methodologies to meet users' need and business goals. Having technical skill alone is not enough. That's what software engineering is trying to tell us. That if you have only technical skill is not enough. You have to follow methodologies, procedures, processes before you can achieve a good software. And that is the goal of software engineering. So you have to understand the principles, the processes, the methodologies of software engineering before you can develop a high quality software that can adapt to changes and continue to meet user expectation over time. So in this lesson, you are going to introduce the field of software engineering, including the importance, the concepts, the methodologies, and the roles and responsibilities of software engineers. At the end of the course, at the end of the 3 months, you are going to become a software engineer. Maybe, what's your name? So you are now Engineer Ibrahim Farouk, just like me, Engineer Chidi. So some people say, oh, where is the engineer? They say, okay, is he mechanical engineer? Is he electrical engineer? I say, no, software engineering. Some that don't know, they feel like, is there anything like that? Those that know will rejoice in their mind because they know, the quality that software engineers bring on board. What's your name? Yusuf. Okay, so at the end of the 3 months, you can now say that you are Engineer Yusuf and you'll be proud of it. Hello, what's your name? Oh, sorry. She's part of us now. She's an engineer already.
Yes, I'm actually an engineer.
Definitely.
Engineer.
Oh, okay. Then how come you are now administering IT things? Okay. So name, please.
My name is engineer.
Okay, an engineer already. Okay, which field are you?
Chemical engineering.
What?
Chemical engineering.
Chemical engineering. So you have an advantage of knowing what engineering means. That engineering is not just skill, it has process. It's because of that process that you study engineering so that you know the process. That's the difference between a mechanic, a motor mechanic, and a mechanical engineer. There is a lot of difference between them. So what is software engineering? Software engineering is the process of designing and building software systems that are reliable, efficient, scalable, and meet both functional and non-functional system and customer requirements. So what I'm saying here is that this software engineering is a process. It's not just a skill. There's a process you have to follow. And that's why you're learning, you're studying it in school. So that you can meet functional and non-functional requirements. Functional requirements are those ones that the owner of the software tells you, I want a software that will be able to allow me share light if my neighbor doesn't have light and I have light, so that I can share light with him. That is what the person needs. That is functional requirement, if you are able to achieve that. Now, non-functional requirements is you now as an engineer, you now think out of the box. What if, as he's sharing this light, another person hack it from the middle and take the light or tap some of it? So you now start thinking, okay, how will I protect that system so that a third party cannot go in unauthorized? You are now thinking about non-functional part. Non-functional doesn't mean it doesn't function. That's what I'm saying. Non-functional means the owner didn't tell you to do it. It's not part of the equation, but it's something you must do to achieve that aim. Another thing, you now start thinking, okay, how can I reduce the bandwidth of data that this guy is using to transmit? Because if he loads data now, let's say he load 20 gig, and by the time he transfer that light, the 20 gig is gone. The person will not be happy using that app again. But he didn't tell you that. Oh. He didn't tell you make it minimized megabytes. He didn't tell you that. But because you are now an engineer, you think out of the box. You now know that I need to minimize this. So you start working towards it. Non-functional requirement. So non-functional requirement, like I said earlier, doesn't mean that this thing didn't work. No. What it means is that you are going beyond what the person asked you to do. You are putting in place things that will make that thing to work efficiently. Do you understand that? Software engineering encompasses all aspects of the software development life cycle. So there is a life cycle that software development undergoes from beginning, just like in biology, they call that in metamorphosis. Do you remember metamorphosis? How eggs can change to pupa, change to larva, change to that kind of life cycle. Software undergoes that kind of life cycle. So an engineer oversees it. An engineer makes sure each life cycle of the software is implemented. And that is the process that we are talking about. And that process includes requirement gathering, to design, to implementation, to testing, to deployment, to maintenance. We're going to talk about these things more. Software engineering uses engineering process to build software that meets users' needs by applying engineering principles to ensure that the software meets the requirements and solves the problem of the customer. I want you to see the difference between a software developer and a software engineer. A software developer will just jump in, bring his keyboard, and start typing code because that's what he wants to do. Functional requirements, because the user have said, I want a software that will transfer light to this place. So he jumped into his keyboard, developed a software that will transfer light and submit it. He didn't take care of documentation to think that, okay, what if I'm not there tomorrow? Who can help these people edit this code? He didn't think about it. He didn't think about, oh, what about the data transfer that's consuming too much? How we do it? He didn't think about the security of the system. He didn't think about how to control the wattage of light he's transmitting so that he doesn't burn something in the other person's house. His own, he just type it and he developed what the person wanted to develop and off he goes. That is a developer. But a software engineer takes care of processes, principles, things that must be in order for this system to continue to function. We mentioned some of those keywords. We said reliable, say reliable, efficient, scalable. These three keywords are the outlook of an engineer. It's not just to build a software. This software you build, is it scalable? Can we add more people to use it? You have developed a software that I can send light to my friend. What if I have another friend? So would I have to need to develop another software to do it? Or can this one be touched a little to scale to that way? What about efficiency? Do I need to spend everything I have just because I'm sending light to this guy? Or will his house get burnt just because I'm sending something to him? Do you control? So those checks and balances are what makes engineering, software engineers better or even superior to ordinary developers or programmers. The importance of software engineering. We've talked about some of it. Efficiency and scalability. Software engineering practices help in creating software that is optimized for performance and scalability. It's not just to function. We have moved from function to performance. Because if I ask you to develop a software that will make me transfer light to my friend, and you develop it and it's not transferring that light, I will not pay you. So even ordinary programmer can do whatever you want him to do. But the engineering person now comes in and thinks about efficiency and thinks about scalability. That is where the difference lies. Now, quality assurance. The use of structured methodologies and rigorous testing processes ensures that software is reliable and meets user requirements. So an software engineer does what we call quality assurance. You have to test this software beyond normal ruggedity. You have to test it when the network is low. You have to test it when the power is high. You want to test it when there is low current. You have to test it in many conditions to be sure that the quality of that software is assured. Another reason you have to go to a software engineer is cost effectiveness. We have already said that if you didn't make your software to scale for example. Next, when you want to add another user, you have to go and redesign it. But if it is scalable, it can add as many people as you like and it's continue to function. We have also said about quality assurance. You have to test it across all board. Now imagine if when you make that transmit, because that's what the user says is make me transmit light. So when you transmit the light, it burns something in that person's house. But the programmer has been paid. His job is gone because what you asked me to do is to transmit light. Are you able to transmit light? Yes, pay me, pay him in goods. But you didn't think about the cost effectiveness where something will be burning in that person's house and he'll be getting money to repair it all the time. Or the software is consuming a lot of data to transmit and the person is spending too much to transmit. Or he needs to add another person. He now start all over again, developing a new software again. So when we talk about cost effectiveness, it is cheaper for you or anybody to call a software engineer. It's not like when you're building house. If you just they have builders, they have architects. If you just call a builder is like a mason. He will just get block, get mortar, and start building without planning or without even considering the structure of the house that he's building. That's why sometimes you have collapses, you have building collapse here, collapse here, because the quality assurance was not there. Sometimes, and you know, natural disaster can occur, but most of the times, proper planning, proper engineering of the house can protect it more. Why we need software engineer documentation? We have mentioned quality assurance, we mentioned reliability. can see me? Okay. All right, people online and people physically present. Sorry for the break in transmission. We are trying to reconnect. All right, so before now, we are talking about the software engineering process, which we say that when we follow it, we become the real engineers for producing software. One of the first, or let me say the first process is requirement analysis. What do we do with requirement analysis? The person that want to build the software have asked you, I want you to build a software for me that I can use to transmit light. That's just what he wants, but that's what is in his mind. Will you just now go home and start coding? If you do that, you didn't do requirement analysis. For you to do requirement analysis, you have to gather and define the needs of the person, if it's one person, or stakeholders, if there are many users, to ensure that the software meets their expectation. So what this thing means is that you have to go back to that person that gave you that job and say, okay, sir, what do you want to use to do this transmission? Is it your phone or your laptop? That is what requirement gathering is. It's not just to hear what they want. It's like, let me see whether I need to. It's not showing. Okay, let me let me reload it. It should be showing now. It's not. No, it's not me that's supposed to be shared. It's showing now. Okay, thank you. Okay, so I just moved back. You did move. Is it where you are? Check. Check again. Is it where you are? Okay. All right. So you need to go back to the person and say, what do you want to transfer this light with? Is it with your phone or with your laptop? You say, my phone. You record it. Remember, he didn't tell you that before. He just said, I want to transmit. But what you are doing now is called information gathering, or what we call requirement analysis. You have to go and get what is required for this software to function, for it to function to his expectation. What do you want to transmit this light? You say, my phone. You record it, phone. You go back, you go to that person that will receive it. That's why we use the word stakeholders. It's not only that person that say he wants the software that you will interview. You have to also interview the other person, all the users. You go to that person and say, sir, your friend wants to transmit light to the software you're building. How do you want to know when the light that he transmitted and the one that the national grid brought to you? You say, okay, I have a blue bulb here. But I want, if you transmit, let it show red. And if it is from power grid, let it show blue. You record it. Because these are the things that when you build the software and it's functioning this way, the two parties will be happy because you have met their expectations. Unlike when they just say, build a software for me to transmit light. You just rush and go and build it. You didn't gather more information to know more of what is required of you. What are some of the activities you will do? Number one, Identify functional and non-functional requirements. We have already discussed non-functional requirements. We say that non-functional requirements are those requirements that they did not tell you, but you know that you must do them for that system to be effective, scalable, and cost-effective. So those other additional features that you will add to the software that they may not even see. As they are using the software, they won't see it. That's why it's called non-functional. Not as if it doesn't function. So I think the grammar here needs for you to understand it as an engineer. Non-functional requirement doesn't mean it doesn't function. It means that users will not see it. It works at the background. For example, the security of that system, they won't be seeing it. Just like you're using bank app or you're using WhatsApp. If they tell you the amount of security that is behind WhatsApp, you marvel. But you won't see it. What you know is you want to chat engineer chain. You just get my status and start your message, click send. The message come to me. If they tell you what is happening behind the scene for this message to get to me, you marvel. Those things are what they call non-functional requirements. The user don't need to be bothered with it. The owner don't need to be bothered with it. But if you don't put those things into consideration, the system will not even function at all. Or as it is functioning, people will be dissatisfied using it. So in the activities of gathering requirements, you must identify those functional and non-functional requirements. The next one, you must prioritize requirements and document them in a clear and detailed manner. In these requirements, which one will I do first? After this one, which one comes next? Which one comes next? You prioritize it. And then you must communicate with stakeholders to refine understanding. After they have told you what they want, you have recorded it, and then you have gone back home, analyze it, put them in priority. You have to go back again and say, sir, just to clear, you said when light come from your friend, you want to see blue bulb, and when you come from NEPA, you need to see red bulb. He said, yes, yes, that's what I want. You know, but sir, what you have here is only one bulb, and it's not even red or blue. How will you not want to do it? He said, sorry. So that means we need to buy another wall socket or lamp holder for blue bulb. You know, say, okay, okay. You now go and buy it. But if you just take his word for it, he said, I want here to be blue bulb, I want here to be red bulb. You just go home and you code it that way. After coding it, you put it and he said, I'm not seeing any red bulb, I'm not seeing any blue bulb. This thing you designed is not working. After all, I told you before. Because you didn't follow the engineering process. So you have to communicate with them, not just the owner. All the when we say stakeholders, you mean everybody that is involved in using that software. They need to understand what they have told you. You tell them back, is that what you want? Is that what you said? They have to give consent or modify it. Then, after you have done this, you now prepare what we call software requirement specification document. So this is now like your working tool because you are done getting all the information you need from them. Both the ones that they mentioned to you, which is functional requirement, and the ones you, as an engineer, you know you have to integrate to make this thing work. That's the non-functional. You have gone back to them again to be sure that they know exactly what they say they want. They give their consent. You now use this thing to prepare a software requirement specification document. That is now what we now go home and start working. So that is the stage one, information gathering or requirement analysis, as we call it. So now that you have gotten the information of what they want you to do, you now go home and start designing. And when we say design, the objective of it is to translate the requirements into a blueprint for system. What are some of the things you will do? The activities you will do here. One, you create a system architecture, a database schema, and user interface design. So you just make these designs. You know, when we say architect, you see architects. What do architects do? Draw. What do architects do? Mr. Musa, what do you tell me your name is? Sorry. Abraham Farooq. Okay. What do architects do? Do you know the people architects?
Yeah.
What do they do?
They design house.
Good.
Yes.
So that design is what you go home to do. Just draw it. Start drawing on your paper. Start drawing. You are going to learn each of these things. This is just an introduction. We're just telling you orally. That's not how the class will be. Then in our next class, all of us are going to get dirty with drawing because that's the design that you're coming here to do. You're going to be drawing software, see how to draw it, sketch it, both the database schema, you're going to draw the database, all the relationships, you draw it, you know how to design, model a database. You're going to learn how to draw user interface. How will the user click here? Will he click here? Will he scroll down? Will there be a drop down? You'll be drawing all those things until you bring out a perfect picture for software. That is what the design is. And what will help you do it is that document that you have designed before, you bring it on board, and now you start looking at it and be doing your sketches, just like an architect. Then after you have done your drawing, you've done the sketches of okay, this one will be here, drawing. The next one now is to define the components and how they will interact. So in the components here, we mean button, text box. Do you know what is text box? Button, drop down, menus. Start mentioning those components, and then how do they relate? Like if someone click this button, what should happen here? If someone type in data here, where should it go? You start designing those interactions between those components. Then you also create reusable and modular components. In this introduction, we'll talk about reusable, maybe in the next slides. So you see the need for reusable components. And we might be using JavaScript for the practical. So you also learn about components and reusable components in a practical, in a skill form. So those reusable components are components or part of the software that you don't need to do twice, even though they're going to use them in many places. And that's where scalability comes in. So you build it as a component, and then that component can now be reused and reused and reused. Just like window. Like if you check this window is the same size with this window, the same size with this window. If you also check this one here, they are the same size. So what they in software engineering, just build only one and keep it. When they now say window, you give them a copy. That original is still there. Another window, copy. So because you have built it as a component, you can now put it in many places without going back to start measuring again, putting glasses, measuring, wasting time. So it is at design time that you construct all those things and keep them. Then when you are done, you now produce another document that is called system design document. So this system design document now will contain the architectural diagrams, the user interface prototypes that the programmer or the developer will now take and work. Are you part of the class? Okay, I think you are too far away, but it's okay. What's your name? Noel. Okay, you're welcome to the class. So remember, we have produced two documents so far. First, we have produced the software requirement specifications. Who can remember what is in that document? What will that document contain? Noel, what will it contain? Okay. Ibrahim, what will the SRS contain?
Um, uh, Priorities like how the software is supposed to like the categories of how to implement the software. That's the information, the how the activities are supposed to just be
Okay. What will SRS contain?
content.
What will be inside that document? You say it's a document. If you open that document, what will you see inside it?
The main content information.
Information about what? Every document contain information. How can I see people online? because the question also relates to them. We have talked about two different documents so far. One is software requirement specification. The other one is system design documents. So what does each of the documents contain? So first, SRS contain the requirements, what the software should be.
She said, I can see them in the stream, that place, that stream, so you have to switch it. You need to know to see the
So how do I see them?
comment.
Okay. Okay. I'm seeing responses now. Okay. Okay, that's great. Louis, I can see you. Savior Moses. Okay, that's great. Abaka Gambo. Yeah, you're welcome. Okay. Okay. Dual Joker 99. I think sometimes it's better you use your real name so that we don't call you what's your name. What's not your name? Umar Mohammed. Okay. Ahmad Al Majiru, if I call the name well. JJ Ward, Victory Wala, sorry. Okay, that's good. You guys are welcome. All right, so we have produced two documents so far. As we make progress, we see a lot of documents that we're producing. And that is what will form the software documentation. Like I said, we are going to spend the whole day talking about documentation or even more because it's the key of software engineering. So we've talked also two things. Remember what we are discussing? The processes, software engineering processes. Number one is to gather requirements properly. Don't just take the owner's word for it. Do a software for me that can transfer money to another person. That's just the basic requirement. You have to go back and find out what is needed. What are the expectations and all that. That's the requirement. The next is to design that requirement. That thing the person have said, now you now make a design of it, make sketches, make diagrams like an architect. Then the third one is the implementation. Now that you have known what they want you to do and you have designed it and selected the best technology to use, the next one is implementation. So when we talk about implementation, this is now at the time you can now hire a programmer or a developer. It is at this point now, if you are an engineer and a developer too, like me, Engineer Chidi, I'm an engineer and also a developer. So if the job is something only me can handle, at this point, I can now keep my paper aside and open my laptop and start hitting the keyboard. But if you are a software engineer but you don't develop or you don't want to develop, it's allowed. You now go and hire a developer or a coder at this level C that we are now, implementation side, because we have done the engineering part, basically. So the person now, the developer or the coder, will now come and start writing code on his keyboard. He will now be looking at your design because we have already told him in this software we need button to be here, we need a text box to be here, we need a drop down here, we need the menus to be vertical, because you are the one that understands what the user wants. The coder, the developer will now be looking at that your document and be developing it. Even if you are the one developing it by yourself, you will still be looking at that document to guide you so that you don't make mistake or omit something. Then another thing we do at this level is what we call version control. So you have to get the software into Git. Have any of you heard about Git before? Okay, that's good. So it's part of what we will learn. We are going to do them practical. This is a practical training that you're receiving. You are combining intellectual and skill at the same time. That is, you are learning it like those who spend 5 years in school to do software engineering. You're also learning it like someone who went to a business center and I want to learn it as a skill. So it's a double win for you. It's a double win for you. So Git control is where you write your first code, the code you wrote today, you keep it here and you go. Tomorrow you come back, you write again. When you are done, you look at that document that you have written. As at the time you understand the code, what is required, you look at that document and you look at what you have done. Oh, I didn't do this one well. You now go back and you're doing it well. As you're doing it well, you don't destroy the first one you did. You just keep it and call it version 1 and start doing this update as version 2. That's what Git is used for, and that's what it's called version control. So that if if for any reason maybe you are angry today or something happened and you scatter the code, you don't have to just get lost. You have to now refer back to that original one, the initial one you have done, and start doing it again. So that is what version control is. Then at this implementation side too, they have to follow coding standards to ensure a maintainable and a readable code so that someone can look at the code and know what they have done. One way to do that is using what we call comment. We'll still learn about it practically. Then at the end, there will be source code files, code comments, and documentation. So the information you will add to the document now is the source code. Source code is that typing, that code that that person is typing. That's the source code. You're not going to take it and put it as part of the document. So notice that at each stage of software engineering process, there is documentation. And maybe in your exam or test, you're going to ask, mention the stages, the processes, and then state the type of document that will be produced at that stage. The next one is testing. So you have gotten the requirement, you have designed it, the programming has been done, you have to test it. So the aim of the testing is to ensure that the software works as intended and is free of defects. So you test the software. You first do the one we call unit testing. So you just test a small portion of it. And then you now test the whole software, whether it works. Then you identify the errors, because that's why it's called testing. There's bound to be errors. There's bound to be errors. Errors in software are called bugs. What are they called?
Books.
What are errors called? Bugs. That is why in software engineering we have, even ordinary programming, we have a terminology we call debugging. What do we call it?
Because
Debugging means correcting the errors. Bug is the error. Debugging is correcting the error. So as soon as you start testing, expect that there will be bugs. So when you see those bugs, you don't panic, you don't condemn the work. It's normal, it's natural, it's acceptable. It's part of engineering process. So it's not like in the first testing, you see error in the code, you say, oh, this guy don't know what he's doing. No, it is acceptable to our field of software engineering. So you debug it. And one thing that will help you debug is of course, the documentation. You have to look at it, know what has been done, know what is expected, and then bridge the gap. Then you now also conduct performance, security, and usability testing. And this is where the one we call non-functional are now coming. The programmer will just do the functional one. Yes, this guy is able to transmit light. And they want to run off, you say, boy, come back, sit down. Let us test whether this thing can be scaled. Let us test the security of this thing that you did. If someone wants to hack into the system now, how can your code protect it? You guys will not start talking about it. So when you have done all this testing, the document we produce now is the test results document, the bug report document. You have to keep these two things and add it to the document that you are producing. At every stage, you produce a document. When you are done with the testing and debugging, then you deploy the software. So deployment means you now give it to the user. If it is online, you host it. If it is a mobile app, you put it on the Google Store. If it is an offline system, you install it in their laptops so that they can start using it. That's what is deployment. So what we do at that time is to deploy the software in the production environment. I've already defined environments, whether it is web, mobile app, or offline system. You deploy it in that place. Then you provide documentation and training. Some owners, some of the people that own software don't even know that there's something like documentation, especially those who are used to hiring programmers. Who don't know about documentation. So what we do as software engineers, if they didn't mention it, ethics demand that you give it to them is their own. They own it for your information. But if you are now the person that wants more money, after doing the software, you give them their software. After some time, you tell them about the document and they have to pay you again. I've done it before, but at the level I'm operating, my conscience doesn't allow me to do it again. When I was looking for money, I'm still looking for money now. But when I was looking for it, like as a beginner, when I have a whole lot of things that, man, let me hold this cash. If I develop software for you, I will not give you the document. That is because you will not ask. But now, whether you ask me or not, I will say, all right, take your documents. It's your own. And if they find out later and tell you, you are that's why you are being trained. Remember that it's their own, you must deliver it. You understand? It's their software, you must deliver it. I mean, it's their documents. It's part of what they pay for. You have to do. It's not like where you buy new TV. There used to be document inside it, is it not? That is the document you are talking about. That document you see passed through this process that you're talking about. It wasn't somebody did not just sit down and type it. No. At every stage of the development process, a document is produced, they keep it. At every stage, the document is produced, they keep it. Even during the time of testing, they keep those documents, and that's what they use to produce user guides. Some of the software we use, like Microsoft Office, you see that there is a help menu. That help menu you see there is the document that we're talking about. It was produced during testing. It's part of the testing document. It was when they are testing it, they are noting how users should use it, and they use it to write that document. So it's supposed to come with the software as a pack. Now, if a company is hiring you, because they will also have consultants, the consultant will tell you right there and then that at the end of this software, we need the document to don't go play with us. And you have to give it to them. You have been told now that is there. All right. So after deployment, you have installed the software or you have hosted it or you landed it in the app, you give them the document and the user manual for training. Some can even ask you to train them. Then after that, we now come to maintenance level. So at this maintenance level is where you, after giving them the software, you stay by and wait. You don't have to give it and run away. So that if anything happen along the way, let's say that the software you installed it on this laptop is an offline system, and the man lost his laptop. When he buy a new laptop, you have to come and install it again. And if there are configurations, you make it. But let's say that the man that is using red bulb to indicate when light has come, all of a sudden, someone comes to his house and say, "Oh, why are you using red bulb in your house? I don't like red lights." The man asks, "Okay, let me go and buy green bulb so that they have the peace." You now go and buy green bulb and fix. You have to recode the software to recognize the green bulb. That is what is called maintenance. So maintenance includes updating. Maintenance also includes correcting errors you didn't see as at the time of testing. Because we are humans, we can erroneously omit what is important. So as they start using it, they now discover that this thing is burning. Anytime this man transmits light, it burns something on my house. And maybe you didn't foresee that. They call your attention. You now have to go back and try to correct it. So we have two types of maintenance: corrective maintenance and preventive maintenance. In fact, we have three types of maintenance: corrective maintenance and preventive maintenance. So preventive is the one you have already foreseen and you try to control it so that an error doesn't occur with it. Then corrective maintenance is when error occur based on the system you have developed. Then we have updation. That's when you now update. That one now, it's not an error per se. It's not a fault. They just want to add more feature to it. Yes, maybe the man now he doesn't want to send light alone from power grid. He now want to be sending light even with his generator or solar. So you now want to add that as an additional feature. It's an update. So it's not a fault. All of them come under maintenance. And each time you maintain a system, they'll pay you another money. The terms of payment depends on you. Yes.
Alright, so please, I really don't understand the parts where you see you have three types of maintenance.
Okay.
That is the preventive maintenance and the corrective maintenance.
Mm.
So the third one is what I don't get very excited
Okay.
because from where I stand, you have two,
Okay.
so which is both the preventive and the corrective.
Yes.
So the preventive is for you to prevent the faults
From coming, yes.
and the corrective is that the fault are occurred and you correct it.
Yes.
So the third one is what I really do.
Okay, let me draw us a little back down the line. We talked something about scalability as part of software engineering advantage. You write a software that can scale. Scale means it can go beyond the initial plan on its own without you adding more load to it. So now, when we talk about the top update, the third maintenance type, which we say is updating, and is not corrective and is not preventive, it's an addition. That means this software, okay, let me give you the scenario. It's like you didn't come on time. The scenario we are doing is someone said, I want a software that will allow me transfer light to my neighbor or my friend. Anytime we have light and they don't have light, I can transfer light to him. That's the software requirement. Now, after building that software, the person now come and say, I also, that is, you have deployed the software, is working the way they want, they have paid you, you are gone. But now, they might now discover that NEPA light is not enough. I also want my gen to be transmitting the same light to this person. So now you're going to build additional software that will do that. That is an update to what exists. I want to think of a live example. Like a lot of it, all this software that we use, which window are you using? Window 8. Okay, I'm using Window 10. Do you have a laptop? Do you have, what window are you using?
It's
Window 8 still. So which window are you using, sir? 10. Okay. 10. So you're using Window 10, you're using Window 8. There was a time Window 8 is the current window. After Window 8, they now produce Window 10. In fact, they produced the one they call 8.1. They now come to Window 10. They didn't do 9, they just jumped to 10. That Window 10 is built on top of Window 8. They didn't start all over again to build it. It's just an update. So that update comes under maintenance because you are done with the work. Maintenance is an after-sales service. If you understand it from that point, maintenance is after-sales service. You are done with the agreement. You have delivered the software. They have paid you. Both of you have moved on. If they contact you again concerning that software, it is called maintenance in the engineering term. So whatever the reason be, whether to correct something or to add what does not exist. You know, when we say correction, that means you are the one that made the mistake when you are doing the software. So you come and correct it. But this one now is not a mistake. It's something that doesn't exist. They want to increase the capacity of the software. This is what differentiates you from a programmer. Those guys will tell them what you want them to do, they will sit down and start doing it. They don't follow this process. This process is what makes software development, software engineer to be a software engineer, because you have to follow engineering process. Solving the problem is not enough. You must follow it as a process. You must follow the procedure before you can now say it's an engineering process, because there is an engineering principle, and that is you must gather more information from the user. The person that say, I want to transmit light to my friend, I want a software that will do that for me. That's just what he told you. And it's okay. How much? You say 50,000. You go and start the book. You are not a software engineer, you are a developer or a programmer. If you're a software engineer, you are going to take your book and paper and go back to that man and say, sir, this light you want to transmit to your friend, what do you want to be using to transmit it? Is it your phone or your laptop? You say, my laptop used to, the battery used to be stopped. Let me use my phone. You note it down. You want to use phone. You now say, do you want to run a cable or do you want to do it wireless? You say, running cable. I don't have money for that too. I will use wireless. You now put wireless. You now ask again. This is called information gathering or requirement analysis. That's is part of engineering. In fact, it's the first engineering process. You have to gather more information beyond what that person tells you. And the information, you're not going to gather it from that person alone. All the stakeholders are all the people that have access to that system. You need to interview them. So you have to go to that his friend that you want to give that light. Okay, sorry, your friend wants to be giving you light through the software that you are developing. How do you want to receive this light when it comes? You say, okay, I have a cutout now, so I want it to be coming here. You say, okay, you note it down. Do you need any indicator like alarm or say alarm used to disturb me? I don't like if I'm sleeping, something disturbing me. Just use bulb. If I see bulb here, I know that it's okay. You must gather all this information so that you can satisfy both him that is doing the software and the person that is receiving it. If you just take his word for it, do a software that will transmit light and you just rush and do it, the software is functioning, but they may not be satisfied. So the first process in software engineering is requirement analysis, information gathering. The second one is design. So you now go back and bring your book and paper and start drawing. That's why we use the word here, architect. So you can also claim, software engineers can claim that they are software architects. It's an approved term. If you search it online, you will see there is a word called software architects. And it's borrowed from the building architects, the people that make design, structural design, building design. That way, that same process is what we do. You have to go back home, get your book, get your paper, and start drawing. They used to draw software. You start drawing it. You draw the schema of the database. You draw the user interface. You draw the security architecture. You draw. You have to draw, cancel, draw until you design a system using that information that you have gathered. When you are done with the design, you now take it to a developer. If you are not, some software engineers are developers too, some are not. They are just engineers. So if you are just a software engineer, you hire a developer. That developer will now use that document, that designs, those sketches, just like when you are building a house. After an architect has drawn the house plan, they now give it to builders or mason. So the mason will now be looking at that drawing and be putting blocks. So that is what developers do. They will just put blocks, or the programmers, they just put the blocks from the design that you have made. And that is what we call implementation. You have gathered the data, the requirements, you have designed it, now to implement it. That's the third step. The fourth process is to test. After designing, you must test it. Don't just design and hand it over. Remember, there is supposed to be a bug in your design. Even when you use ChatGPT, it will still tell you to check what it did, that it is not perfect. So after designing a software, don't just hand it over and test it by yourself before you can be sure. And when you test it, you will see error there. It's certain. So when you see those errors, don't panic, don't condemn the work, whether you're the one that coded it or another person coded it. It's an allowed process in software engineering. Bug is allowed. But once you see the bug, document it and then debug it. Debug means correcting those errors. So that's the testing. After testing, you now deploy. And as you are deploying, you give them the document or user manual that will help them go through the system when you are not there. Then the maintenance can now start happening. As they are using it, if they meet any difficulty, they call you. They employ another staff that is not the one that you trained before. You have to come back and retrain them. They want to expand the scope and the functionality of the software. They call you again, come and update it. They are using it and the system crash. They call you, oh, this thing is crashing too much. You go and check why it's crashing, find out the error, correct it, and they continue going. That is maintenance. And remember that for maintenance, they will be paying you. That initial payment expired as at the time you give them the document of the software. You have trained them, you have given them the document, they complete your fee, and you go. Any other time they consult you, they will pay maintenance fee. It's allowed. So what smart organizations will do, when you are giving them quotation, they will say, how much are we going to be paying you for maintenance? At that early time, the system have not started having issue. So you will charge them less at that time. You can even say, okay, pay me maybe 50,000 a month. Or if you put it all together, 600,000 a year. At that time, it's cheaper for them. But if it's an organization that don't know, they won't tell you about maintenance. Then when it start happening, you can, because by that time you are holding them at the wrong place. If anything happens to that software, they can't be using it, and they won't go back to design a new one. There'll be no time. So anything you charge them that time, they will pay because it's not written. But if it is written on the quotation, you can't go out of it. It's a binding document. It's a binding agreement. However, what I'm trying to say is that maintenance is being paid separate from the development fee. Now let's look at some principles. Yes.
Sorry, I have a question, sir.
Hmm.
Uh, Software engineering, this is my first class and I've not been in this class before.
Okay.
For me, I don't know
Yes.
for the rest. This is my basics.
Okay.
So, sir, and if it happens that by tomorrow I'm going to be a software engineer,
Yes.
and then in this aspect of number 4, which is the aspect of testing,
Mm.
you know, I'm being called to build a software for a company.
Mm.
So I don't know how to put security into this software. Is it mandatory that I get the aspect of cyber security to inculcate encryption on the software? Because we're mentioning things like, in software there is user interface and user experience.
Mm.
So, and you also make mention that you can be a software engineer and not even have knowledge of coding. Is that
Yes.
possible?
Yes. Not no. You have there's no difference between knowledge and skill. There's no way you will have the knowledge of. If you don't have the knowledge, you're not an engineer. It's just like asking an architect, do you have knowledge of building? He's sure we have it, but you may
Because
not
you're
have the skill.
saying you have to make, you have to involve the activities of programmers
Yes.
into it. So now, if we design a system now, I want to take the integrity of the system. That's where you have to bring in cyber security, or you'll be the one that will put the security into the system.
You are asking question on C, on the third process, which is implementation. Remember that the first one you have gathered all the information they need. You came late. Initially, we have
We're talking about number 4, the fourth one, which is testing.
no. You are talking about number 3. Your question will fall under number 3. I will explain.
Okay.
Yes. So we talked about functional requirement and non-functional requirement. Non-functional requirement is a statement that can be misleading to someone that is not in the engineering, that is not a software engineer. Because when you say functional, you think that it's something that is working. Non-functional, you think that it's something that is not working. But that's not the meaning. Functional requirement means those ones that the person have told you that they want. For example, I want to transmit light to my friend. That's what the person wants. If you're able to do software that will transmit light to that guy, you have done what he wants. But that is ordinary programmer can do that. In fact, you are not even the one that will do it. The programmer will do it. Come to think of it. But what now makes you a software engineer? That is the non-functional requirement. Why we call it non-functional is that the person did not ask you to do it for him. they won't see it working. They won't see that non-functional. They won't see it functioning. That's why it's called non-functional. To them, it's non-functional because they are not seeing it. But you know you have to put it in place. For example, now we've talked about security. That person that is transmitting that light, what he knows, I want to transmit light. He didn't consider what okay, you're using your phone to transmit this light, and you know it's internet based. What volume of data will it consume to transmit that thing? Is it if I load 20 gig, I just do one transfer and the whole 20 gig is gone? He didn't tell you that. But you know that as an engineer will now know that I don't need to consume a lot of these guys' resources. You now build in something that will reduce the consumption of data. That is not functional. You also think, what if someone hacked this light? If you transmit it, the person now gets light and this person get light, and this guy's meter will just be going down quickly because two persons are now using it. He didn't ask you to block another person, but you know that you have to do that. That is non-functional requirement. All those things you know you will add to make the software work to the satisfaction of these people. They didn't tell you about it, but you know about it. Just like we're talking about security. Anybody that asks you to build software will not tell you about the security part of it. You will know by yourself. Now, after the design and analysis, you have seen that, okay, this non-functional requirement is needed, this non-functional requirement is needed to make this thing functional. You have gathered it. You now come to implementation. Now, look at the question you're asking. Assuming you discover that this software needs security, am I the one that will put the security, or will I get another person? Is that not what you're asking? When we say implementation, all those things that you have designed, this is where it will come to reality. Now, at this point, if you have, I already said it, if you are a software engineer and you can code, go ahead, code it by yourself. If you cannot code, hire a programmer to do it for you. Have we discussed something like that here? Yeah. So if you want to put security and you think that this security is beyond what you can do as a skill, go and call a cybersecurity person to come and do it for you. It is allowed. At this implementation stage, you can hire anybody. Okay, take for instance this light thing I'm talking about. If the person that want to say, okay, how I will know when light has come through my friend? I want this bulb to be blue. But if it is from power grid directly for me, I want the lights to be red. I'm not an electrical engineer. I'm not going to do wiring for him. But at that time, I have to go and call electrical person to come and wire this thing. And then I will not tell him, of course, I already have a document. And I say, when power passes through this place, let this bulb be on. And when power passes this side, let this one be on. And then buy blue bulb and green bulb. I will not be the one to go to the shop and say, sell blue bulb to me. I can send a boy to do it for me. Implementation, you may not be the one to do it. That's the answer to your question, right? Okay. Okay, so we are now entering the design engineering principles. Engineering principles. So we said that software engineering follow these principles. Number one, modularity. So when you are building a software and the software is complex, in fact, almost all software are complex. We have not seen a software that is just simple. That is why. Okay.
Is it all the maintenance that payments is
Yes.
or update?
Update is part of maintenance.
Oh, yeah.
So any type of maintenance should be paid for. If you now say don't pay me, that one is now your own magnanimity. Maybe you are doing it for another purpose. Maybe you want the person to pay you by kind, or the person have done something good for you, or you are expecting the person to do something for you, and you do it free for them. That one is wrong. But when you are not considering anything, they should pay you. The one they shouldn't pay you is the document. It's naturally their own. If you refuse to give it to them, they can sue you to court, and the knowledgeable lawyer will hold you responsible, and you will lose the case. But if it is maintenance, they must pay you. If they didn't pay you, either you demand that they should pay you first before you do it, depending on your relationship with them and how you want it, or immediately after you've done it, you demand for your money. If they didn't pay you, you can sue them. So it's a paid service. Oduta, I can't pronounce your name. Adurebemi. I've answered your question. Okay. All right. So, like I was saying, in modularity, I've never seen a small software. That's what I'm saying. Every software is complex. In fact, that's why this word software is a plural. There are certain things from today, you should not be saying again. You cannot say softwares and you cannot say datas. If you say that, I will send you out of my class. And if you say it at home, come here and confess. So that software is a plural on its own. That is to tell you that it's a complex system. So when you are building it, you have in mind that as a software engineer, you know that software is a complex system. It's not simple. So you have to break it into small, manageable, and reusable units so that you can now couple them. We will learn about coupling and when we will start the practical of coding. So you see how you can write small code, and then make them reusable, then couple them. It saves your time. There is something we call dry. Don't repeat yourself. Dry, DRY. It's a very strong principle when you are developing a software. Don't write the same code again. Write it only once. Keep it. Anytime you need it, call it. Anytime you need it, call it. Don't go and rewrite it. If you rewrite a code you have written before, if you rewrite it again, it's a bad. You didn't follow the best practice. You didn't follow the best practice of software development. So they call it dry. Don't repeat yourself or do not repeat yourself. So you must write the codes in a way that you can reuse them. It calls for speed. One other advantage is that if that code is misbehaving, you just correct it from one place. Unlike when you write the same code here, you write it page 1, you write it, page 2, you write it, page 3, you write it. If the code is having problem, you're going to do correction in all the pages, wasting time. And if you forget one page, they will have to call you again because they have paid you for that maintenance. You have to come again to do it, and that one will be free because you have been paid for that particular one. But if you write your code in modular form, it makes it easier for you. So that is engineering process. And you know that you will be the one supervising the programmer because you are the engineer. You'll be the one supervising him. So as you're supervising him, make sure that he's writing reusable codes, component-wise. If you just give him the job and leave him and go, he can just write program for you. Because to them, they are looking at functional requirements only. Those non-functional requirements, they don't consider it. So, like I said, modularity simplifies maintenance and allows independent development and testing. That's another advantage. Two persons can be developing the software for you. Just give this guy what to do, this guy what to do. They will be doing it module by module. When they are done, you can bring all the modules and couple it. Like I said, we'll learn about that coupling when we are doing practical. So, but if they are not doing modular code, it's difficult for more than one person to develop the software because it's supposed to be a continuous process if you don't break it. Abstraction. So you have to hide the complex implementation from users. People don't like something complex. Instead of to say click here, click here, click here, click here before this thing can happen, they will not learn it. They will just get tired. They just want simple. I told you I want to be transmitting light. Just show me where I will click, bam, and light will go. That's just what they want. Don't start telling him, okay, click here to regulate the voltage, click here to protect it from hackers, click here to stop it from punishing your friend something, click here. You say, okay, I don't get time to do all these things. You will see that the software you develop it is nice, fine looking, but they're not using it because it's complex. So you have to abstract, when we say abstraction, hide. You have to hide those complexities behind the scene. Let your code automatically know what to do at the right time. Their own is just to click and it happens. Just like the WhatsApp we are using, just like the bank apps that we are using. If they tell you the complexities behind bank app, you shout. It checks for license, it checks for authorization, it checks for network, it authenticates you and even authenticate the person you're sending it to. At the end, take all your details, both you that send and the person that receive, and send it to CBN. It's a very complex process, bank app. Or are you talking about Uber app? There was a time when I don't know about Uber app. Our office was in Port Harcourt then, and I was the lead developer. I'm still the lead developer, even though I'm in engineering. So the job came directly on my table, and it's my first time. So what I was imagining is, I write a code so that if you have, it's a mobile app now, so if you just click that you want to go to somewhere, the app will broadcast the message to all the drivers that have signed up. The drivers will see it, and anyone that pick it, it will connect to of you. I write that code even sleeping. I can just wake up and write it. I didn't know that there are complexities behind. Complexities like knowing the distance between the driver and the person. Number two, knowing the price to charge wherever the person is going. Number three, there are many people using it at the same time. That means user A can say, I'm going to Ube, and user B can say, I'm going to Gariki. User C can say, I'm going to Maitama. How will the app sync all these people, calculate the money they will pay and all that? I didn't know these abstractions. So I just told the guy that we'll charge him 1 million, and I was thinking 1 million, I've charged this guy. The guy said, you don't think I know what they want me to do? I said, sir, no. Sir, no, I didn't. You think the price is too much? There's a lot of work in this thing. Okay, how much can you pay? Let's do it 800. The man said, I don't know what they want me to do. Like, okay, can I explain what I want to do? I explained that, you see not drivers who sign up on the app, then users, passengers will just click and the thing will broadcast the message and they'll go and the drivers will see it. He said, you actually stated what we want, but the amount you're charging, I'm not convinced. I said, okay, how much? I was now aiming at 500,000. The man said they will go and come back. I said, okay. But you people did not say anything. Like, how much will be okay? They didn't say anything. They just said. So a week later, that my friend that connected them to our company now called me and said, it's actually, you see the people I sent? Give my code for me. I say, those guys, they know we pay. You guys say they don't get money. He said, he now called them. They now told him what happened. He now called me and said, engineer, have you done that software before? I said, no, but so long as I'm a developer, there's no software I cannot. He said they are claiming that the amount you charge is too low. I said, 1 million. I charge them 1 million. He said, it's too low. I now have to call a senior colleague, someone that have been there. And I asked him, sir, if you want to develop this software, how much are you supposed to charge them? He said, maybe like 15 million, 12 million. I said, software. He said, what was I thinking? He was not the one that was not telling me about these abstractions. He was not the one telling me, okay, how do you want to calculate the price for each person? Like someone, because we are in Port Harcourt, so he was using Port Harcourt city. And I said, from where you are to Area 1, how much, or from here to Waterlines, how will your system know the distance and calculate the price appropriately? And I said, okay. And I said, then, how will you see the driver coming from the app? And I said, hey, okay. He now told me another thing. And I said, okay. He told me another thing. And I know that I didn't know what that app is. If you see the functionality in Uber app, you know why it costs. You can't develop that app with less than 20 million now with the current Naira price now. Anybody that say, I can develop Uber app for you, I'm charging you less than 20 million. They're just throwing your money. And you know that if you pay a developer and he just write one code, either your money has gone. In the law court, you can't claim it back. Whether the app works or doesn't work. Do you hear that? It's just like where you take a sick person to the doctor and the person dies in the hand of the doctor. You will still pay the bill. And there's nothing you can do to the doctor. That is how it is in our own field too. Once you have committed money, whether the app works or not, you can't refund the money. The law is backing us up. So long as you're a professional, you have to be a professional member. That's something they call professional membership. Like we have, who knows the professional membership for software engineers in Nigeria? Can you mention anyone? CPN, correct? Computer Professionals of Nigeria, you have to be a member. If you're a member of CPN, even if you damage somebody's computer, they cannot sue you. If they ignorantly sue you, the court will just apologize to you and you go. Yes, I just use doctors to give you an example. If you don't know, just ask. If a doctor is operating on a patient or attending to a patient and the patient die in the hand of the doctor, even if it's the doctor's fault, you can't do him anything because he's a professional. So that's how it is in our field. So if someone go and commit money to a developer, like assuming they gave me that 1 million, that 1 million would have gone and I wouldn't have delivered what they want because I didn't even know these abstractions. So, however, what I'm saying is that there is abstraction where a developer will make sure you put those complexities behind the scene. Let the users just see, I need to book Uber, just boat, just put boat. You click, you put where you are and where you're going. The driver will see it and chatting. You think that is the only thing happening. So many things are happening behind the scene. And that's what you should also do as an engineer. Don't give the people complexity. They already have a lot of complexity on their head. Make your app simple. That thing they say they want to do, show them, click here and it is done. That's just what they want. As a good software engineer, you must do abstraction. The next one is the usability. All your codes must come in modules. We have already discussed it. So that anytime you want it, you pick it up and you implement it or use it. Maintainability. Your code must also be maintainable. Have I gone offline again?
The slide is not changing.
Uh, why? Okay, let me stop it now. Okay, it's working now because I can see it change. So your code must be maintainable because they're going to call you for maintenance. Since you are the one that did the software, they don't have to call another person to maintain it. It is you. And talking about your rights, if they dare call another person to touch that software in terms of maintenance, you thank your God because they will eventually have to call you again, and then you cannot charge them 50 billion, or you will not touch the software. The law is backing you. No other person is supposed to touch that software without your consent. So long as you're the one that developed it, you're supposed to be the one who maintain it. Except you expressly let them know that I'm busy and I have handed you over the document. So another engineer can solve it. And also for your information, if someone developed a software and the company called you to come and maintain it, and they didn't give you the software document, don't try to touch the software. If you spoil their software, they can sue you because you're not the one that developed it. But again, if they give you the document, it's an indication that the initial developer has handled. So with that document, you can now sit down and read what they have done. You will be able to maintain it. That is the number one reason for documentation, maintainability. So that another person can read that document and be able to maintain that software, even though he is not the one that designed it. Because all the processes that you followed in developing that software is documented. Even the initial bugs, when the first software was first tested, is in the document. So from there, you can trace your way down and correct all the anomalies. Scalability. You must ensure that your software is scalable. That is, it can go beyond what it was. Anytime they want to increase, let's say that man that said, I want to be sending light to my friend. If you now have another friend and want to be sending to two of them, you don't need to go back and start designing another software from the beginning. That one you design should be able to, like my friend that asked about updates. So this is where update coming in terms of scalability. So you don't need to start all over again to do a new software. You just update that existing one, create two channels so that another person can access it. So that is scalability. Your software should be able to expand. It should be able to allow for growth without starting all over again. And of course, the future is always changing. So as the future is changing, your software should also be changing. You're not supposed to discard your software because there are changes in human nature. You just do small updates and your software is up to date. Okay, so this is a place that is also important, roles and responsibilities of a software engineer. In fact, this, like I said before, software engineering is so vast that only you is not supposed to handle everything. Like our friend asked about getting a cyber security person. It's 100% allowed because only you cannot do it. In fact, in the white man's land, if you claim that you're a software engineer, they will just grade you by your years of experience. Then they will not make you a supervisor. They will not allow only you to handle all these processes that we mentioned. It's only in Nigeria here where you will do requirement analysis, you will do the design, as engineer, you will do the programming, you will do the maintenance, you will. The white people, they don't. No. Over there, you will just choose one and specialize. They call them subject matter experts or subject matter specialists. It's even important for you if you specialize. That will increase your fee and also increase your worth. It's just like in the medical field, there are general doctors, but if you are a specialist, maybe you specialize in eyes. When there is a health issue that ordinary doctors cannot handle, so long as it's eye, they come and call you. And because it's your specialty, if you don't solve it, no human being again can solve it. Because you specialize there, that's what you do every day, and you are experienced in it. And the money they will pay you is higher. That's why if you go to a specialist hospital, you pay more than when you go to general hospital. That's also how it is in the software engineering. Only you should not try to do all, except you are still on the street hustling like some of us. But if you are in the US, UK, they won't give only you all these things to do. So look at the roles, and like what I'm saying is that these roles now have metamorphosed into fields of their own, specialties of their own. That's what I'm saying. You can specialize in one, but for now, all software engineer must have knowledge of these things before you can now specialize. So you can take different roles and responsibilities throughout the software development process. One of them is requirement engineer. So this person knows how to talk to people. This person doesn't get angry easily. This person is a marketer. He can crack jokes. He can, even if you are angry, if he talk to you, you smile. He knows how to make friends. It's a quality. It's not everybody that have that kind of skill. It's a natural endowment on people. So this person can go to all the stakeholders, no matter their level, and then talk to them and get the requirements. Then we now have software architects, those who have design skills. This PowerPoint I'm using, there's one guy, Godfirst. The guy's name is Godfirst. He's clean at Twitter. If I have a serious uh, PowerPoint presentation I want to make, especially if I'm pitching to funders, people that give money, I will send my PowerPoint to him. If you see this boy's PowerPoint design, you will think it's a website. I don't even know what I would say you think it is. It will look like a graphic, a designed graphic. He won't just use his, even if he's using only text, he will color the background, he will put maybe blue circle, green circle, red circle behind as a background. If you're looking at it, it will look so nice. So there are people who have that skill of architecture rather. So it is part of what a software engineer should know. Requirement analysis, then software architect is part of your responsibility. You don't sublet it. Like we talked about calling cybersecurity persons or programmers. But for these ones, you can specialize in them. Well, you can also decide to be a developer. As a software engineer, software development is part of software engineering. Though that software engineering is like a big umbrella covering them. It's superior to all of them. But you can decide to specialize on being a software developer. In fact, some software developers, a butterfly that think is a bird, can think that they are engineers. But we know that they are not, because there's a lot of things we learn and know that they don't learn and they don't know. So they are limited in knowledge. but you can decide to, as a software engineer, you can decide to major in development. You are a software engineer, but you are a developer. Unlike people who are programmers and developers, there are two routes you can become a developer. You can come from the point of a programmer, so you know how to write Python, so you are a programmer. And because you have written Python for a long time and you have added more programming knowledge, like you can now write SQL, you can now write JavaScript, so you combine this knowledge and you're able to develop a software only. From that route, you can claim to be a developer. But your knowledge and your worth and relevance is limited when you are compared to someone who is a software engineer but have passion for coding and now say, okay, let me stay as a developer. The two routes are different and the remuneration is also different. We also have testers and quality assurance. We like call them engineers too. They are part of software engineering roles that you are supposed to do all these as a Nigerian. But in the white man's land, you pick only one. They won't allow you to do all, only you. You pick only one. So anywhere, any one of these things that you find yourself being more attracted to, put your muscle there, learn it more, so that for any reason you jabber, you become a specialist in that one. There are people that they don't code, they don't collect analysis, they don't do architecture. What they do is testing. Bring that your software that you say you have tested by yourself. They will puncture it. Where you say, okay, you want to send money, type how much you want to send. So you as a developer, you're expecting maybe 5,000, like 5000. Those testers will look at your app. Instead of to put 5, they will type FIVETHOUSS and send it. Something you didn't expect. And because in software, there's something they call data type. Number is different from string. So if you design your own to accept only number, they will put string there and your code will crash. And because they are working for the same company, when they do that kind of testing, the company will now call the developer and say, no. Go and correct this thing. Either you put an intelligence that will translate, yes, that's grammar to numeric so that it will work. So there are people that specialize in testing and quality assurance. That thing you think you have done is working. They will put stress on that software until they punch out error from it. So that by the time the software have undergone that harsh process and come out to the market, no other user can puncture it because they are already software engineers. They know where to look for error. Unlike ordinary users who want to I want to transfer money, just type 5,000 and send. They are not thinking about trying to make this software fail. In fact, their prayer is let this transfer go. They are not thinking of how to make it fail. But this tester want to make it fail. So his own thinking will be, how will I make this thing fail? So there are people who specialize in that. But as a software engineer, you should know all these processes. And we are going to know them because every day we have a class, we learn a new thing. This is a practical course that we are doing. So all these things, we learn them practically. Today is just an introduction for you to hear the things we will do. But we are going to do all of them. Then project manager is also part of what a software engineer does. I've already said it, like the question you asked about getting a cybersecurity person. You don't just get that person and leave him. You have to make sure that what he's doing is in line with the document that you have written. You have to see that what he's doing matches the aim of the software. So you supervise him. If you also get a programmer to do the programming for you, if you don't program, you also going to supervise him. So a software engineer is a project manager because software is a project. So you have to learn how to oversee resources, including humans, and also how to communicate between your team. The team is all the people working under you. You should know how to communicate with them. A software engineer must also learn maintenance. The trick of maintenance is ability to read documents. That is the trick. Whether it is your own software, you have to read the document you have written. That's why you cannot develop a software without creating documents. We've mentioned up to 4 documents that you should create as you continue on the process of software development. So these are the rules of software engineering. Then DevOps. So this DevOps is crafted out from the software project management, and it was made because some developers they will just go and collect the job. They don't want to sublet. They don't want to give a tester. They don't want to give a user requirement analyst. They don't want to give a developer. They want to do it all alone. It is allowed. It's an engineer. There is an architect you will hire. He will draw your house and build it for you. We also do that in software engineering. That was why they produced DevOps. So this DevOps is a special aspect of software engineering. They don't code, they don't do anything. Their own is people's management, systems management. This DevOps, they pay them more than they pay software engineers. Can you imagine? So if I were you, I would start thinking of DevOps. But the problem with DevOps is that you have to be employed, except it is your own company. So you now know that you are managing people. A standalone developer cannot measure on DevOps because who are you now managing if you are the only person? But DevOps, when they get job in big companies, actually big companies that hire them because at that big companies now, they now have a programmer, they have a cyber security person, they have a developer, they have a marketer, they have so they need someone to manage them. This DevOps is actually a child of software engineering. That's why we are talking about them in software engineering. So you can measure on that if you know you have management skill. So you don't need to bother yourself learning how to code as a software engineer. You just measure on people's management, resource management. So what it means is that they want to develop a software, Uber app, and say how much? Say 20 million. It is you that they will give the 20 million. So from that 20 million, you now make sure that your team has data for them to work online. You make sure that there is light or gen or solar for them to work. You make sure that every afternoon you give them food so that they won't get hungry while they are working. You make sure that there's no noise coming to disturb them while they are working. You make sure that they're in the right frame of mind while they are working. So you manage the people, you manage the resources, even where they will host the software. You will also see that it is the right place and it is in the right position. If anything goes wrong in the process, it is you that they will ask. So that's one thing about DevOps. But those people, it's a new creation. It wasn't their ab initio.
Also, the answer, can the DevOps have knowledge of the project manager?
Of course, that's what I'm saying. He's the project manager. They baptized him. This project manager you see here, he got a baptism to DevOps. When they now see the need to manage team, because they now start disassociating people from normal programming to having specialties. So in software engineering now, you cannot have specialties. You cannot say, okay, I'm majoring in coding, in software development, or I'm majoring in maintenance. Or there are a lot of aspects that you can now measure. So you will not just carry the load of software engineering. So DevOps will help to manage the people that are doing not only the people, all the resources, even the deployment. So as part of software engineering, you can choose to be a DevOps. Is allowed. In that case, you may not be required to be doing too much coding. You now focus on management and the deployment of systems. So I don't know how many hours we have left.
So you have 2 days left.
What's the time?
12:49. So we'll finish by 1.
12:49. Okay, so we have like 11 minutes.
So we have to give it the
Hmm? We have 11 minutes.
So you can take questions now.
Yes, I will take questions now. I wanted us
Check
to
online, take the question.
yes. I wanted us to take this software development life cycle, but time didn't capture it. Okay, in our next class we'll do it. All right, so as it is now, I will throw in some questions and then expect you to give me the answers. Um, Let me just put the questions in. So look at these questions. Number one, this is writing capital letter. That's number one. Number two, what will I say? Is it name or list? Could be list. Mm, this should be number three now. So mention um, three roles a software engineer can take. Number four, number five, okay. Let's have you answer these questions. So let me look at people online. Okay, so people online, have you seen the question? Abubakar Gambo, please fire your question. You can type it. Abubakar Gambo online. Can you share the question that you want to ask? While we are waiting for you, go ahead and answer the ones that I have on board. I think someone is trying to say something. Okay, Gambo, all right, all right. Say you have seen the answer to the question he asked. Okay. All right, so I don't know how we do this question. Are you going to answer it here right now and then, or you take it home and then let me have it?
So I can also have the notes.
The slide, Abby.
Yes, sir.
Our big madam is here. She will answer it. Hello, ma. Did you hear what he asked? He said, Can they get the slide? Okay. Because they will need it before the next class so that they can read through and understand it clearly.
So, sir, a good question. So, assuming you have a client,
Mm.
they give you to develop the software for them.
Yes.
So, do they have the right to ask for the code, the document?
We have who will answer that?
Yes, they have.
Wow.
It's their
Give it to
own.
them, they can able to sue you for that.
Yes, because it's their own. You're hiding it.
May I ask a question?
Yes, ma'am.
Who owns the source code? Is it the developer or the
The owner of the company. Okay, who can answer that question too?
It's developer side.
It's the developer that own the code,
It's source code.
the source code. Okay. Any contrary or supportive response? Yes, sir. When you say company, are you talking about the software delivery company or the customer?
the customer, the people that contracted the software
Okay, Moses, what do you think? Sorry, what's your name? What do you think? Who owns the source code? Is it the developer or the customer?
the customer.
Okay. Um, what do you think?
The customer has the source code because it can also be used in another company by the developer. So they have to be in charge of the software.
Okay. Sir, the person there. Are you part of the class? Who's supposed to own the source code? Who owns the source code? The developer or the customer? Why? Okay. So I want us to know that at every look at this. We've said it before, but you are making me to go back to it again. But it's equally good because some persons didn't come on time. In software development process, we say that there are 5 of them. One is requirement analysis, and we say that at each stage you produce a document. Do we say that?
Yes,
So the document that is produced during implementation, which is at the time of coding, includes source code. Are you seeing it here? It includes source code, and this will be in that document. Each stage you produce a document. Each stage, at the end of the software development life cycle, you pack those documents into one big book and hand over to the owner of the business. They paid you, so you can't claim intellectual property here. No, they paid you, so it's their own. If they find out that the document you give them doesn't have source code, they can sue you. You breach the agreement. Except ab initio, 2 of you agree that okay, I'm doing this software for you, I'm not going to give you the source code. They write it down and sign. They can't just say it orally because by law it's their own. Yeah?
Okay, so you guys have to reach an agreement.
You don't reach an agreement, it's their own. The agreement I'm not saying you cannot reach if you think there are some introductions by you and you don't want to give them the source code. You now say, okay, so I don't want you to give the source code, maybe I will reduce the charge. You guys now agree, they sign because it have to be documented as evidence in case. Yes, ma'am.
Yes, all I'm asking is that, in the development process,
Yes,
every developer has a way
he develops.
to run.
Sure.
And yours will be equivalent to
Sure.
as compared to another developer.
Mm.
And sometimes you may even have to maybe something that works on.
Copy it somewhere and produce.
And you use that process.
Yes.
In all of these, there's the balance you want to have in there.
Yes.
So as to not change yourself in the long run process.
Where you catch them is on maintenance. If you are the one maintaining the system, you are still the one looking at those codes. So if you feel so hard about giving them the code, what you might do, it is not ethical. But sometimes you have to also learn the bad one and learn the good one. You don't comment the code. You just write it. You don't follow ethical process. Just write it where another person will not understand it. For example, when you are calling variable name, there's something called variable. You're supposed to give it a name that anybody will understand. But in that one, you can use X, Y, Z, B, what they will not understand to write it. But in terms of ownership, dear sister, it is their own. Because they have the right to discharge you and call another person to come and do maintenance for them. They have the right. Where you can now come over is maybe they call another person and the person spoil the program. They now call you, you can overbuild them. But the code is their own. Okay.
So you have time limits and everything. Some of this source code
Yes.
they are being deployed.
Mhm.
So once you are being called for maintenance or what have you,
Yes.
so how do the developer get access to the source code? Because sometimes, for example, we are building an app, like a moving app.
Yes.
Some companies will not want to review those source code. We want to collect everything, make sure that nothing is in your possession of
So that you don't go and
information. Yes.
yes.
So how does the developer, is it that they have to give access again or how?
Yes, they will give you access again. It is their own. At the moment you handle the one they are done paying you and you've handed over the work, like you are done, they have the right to change the password of the log. It is their own. It's not about somebody build house for you. Can the person after building house take spare of your key?
No.
It's your house. Even in fact, if you suspect that they may have a spare key, you can call another person, change the padlocks. It's your own. The person cannot come and see you and say, okay, so I built house for you, you now change the key. You can't do it. So it's their own. But what you can say, even the source code, some companies, because they know that it's their own, if they catch you using the same code used for them for another person, they will sue you. It's a breach of agreement because it's their own. You're not supposed to reuse it somewhere else. So that is why they sign what is called non-disclosure agreement. They call it NDA. If you are doing software for a knowledgeable company, you will sign that NDA. And don't think that NDA is a joke. The thing is that code is hidden, so they will not know when you use it another place and when you didn't use it. But if someone close to you do have a ball for you and tell them that see this their code, that that's what you also use for company B. If they are interested in troublemaking, they can sue you and bill you millions. So that's the way it is. The code is their own, it's not your own. And you're not supposed to use it another place. You're supposed to sign non-disclosure agreement. That's what it's called.
So anytime you are writing code, it has to be fresh.
You're Africans. Yeah. If I write code for you, I'll just give you a copy. In fact, if I want to develop a software now, it doesn't take me 1 week because I've already written all the codes I need to write in this world. I've written them. I don't think there is a new. What would I even be doing? I'll be writing a new code. I don't know. I have all the codes, and if I write something different, maybe I did a new thing, few new things, because it doesn't have to remain. I will copy it and put it in my code base so that anybody that says do software for me, I will bill you. I will go. That's one thing about software development. It's very once you have built to a stage, it becomes so easy. You can collect a work and do it in 3 days because you already have the code somewhere. The owner of the code will not know. But just like plagiarism, what you need to do is maybe change those variable names so that it doesn't match their own. So that even if somebody tells them that you're using their code, if they come and check it in the law, in the court, they see that the variable name you are calling here is not what you're calling here. You are exonerated. Just like change it. Just like when you are copying Expo from, you don't need to write that person's name. There you should write your name. You just change some things and it becomes your own. So that is it. Okay, the class. I love the class. I love the people here. We are thinking out of the box from the questions we are asking. It makes the class very interesting. But everything that has beginning has end. For the day, I wish the class will continue, but time is not on our side. So if you have further questions, you can ask. The manual will be given to you. Our auntie has given us assurance, but maybe not immediately, but we'll get it before the next class. Yes, and the assignment, we'll reach out to you how to answer it. Yes.
Are we going to be left
I think Auntie is working. There's a group already. If you are not there, find out why. Then meet her to add you if you are sure you're not there. So the question will tell you how to answer the question. Either we will create a Google form so you put your answer there. Yes.
Issue, actually, tomorrow Sunday,
Yes.
I'll be traveling to Kano State.
Okay.
The next 2 Saturdays I will be available.
You connect online. You don't need to be physical.
All right, thank you.
Yes. These people are online. Are you not seeing the people online?
Yeah, because I actually applied what do you call it?
Physical.
Yeah, that's all.
You can waiver it from you. Just connect online so that you don't miss the class.
Yes, I'm going to submit and run through what is next week.
Yeah, with the class for I was even thinking that the hour would be enough for us to run it, the chapter 2.
And
So, no, it's not only you that